Statsproblems.com was used to create this tutorial, which can help us calculate a complete repeated measures t-test. Let's begin by selecting one of the 25 example problems. The question appears in the blue box. A set of population scores are normally distributed. Sample scores are from two related groups. Scores in Group 1 are 8, 16, 4, 8 and 19. Scores in Group 2 are 20, 22, 23, 15 and 20. Alpha is 0.05. Number of tails is 2. What are the results of the hypothesis test, comparing the sample means of the two related groups to each other? Let's step through the solution by clicking on the Next Step button. In Step 1, we calculate the difference scores for all x. The difference score for P1 is 20 minus 8, which is 12. The difference score for P2 is 22 minus 16, which is 6. The difference score for P3 is 23 minus 4, which is 19. The difference score for P4 is 15 minus 8, which is 7. The difference score for P5 is 20 minus 19, which is 1. In Step 2, we calculate the mean of the difference scores, d bar. The mean of the difference scores, d bar, equals the sum of the difference scores, sigma d, divided by the number of score pairs, n. In this example, the mean of the difference scores equals 12 plus 6 plus 19 plus 7 plus 1, divided by 5, which works out to 45, divided by 5, which works out to 9. In Step 3, we calculate the sum of squares, SSD. The sum of squares, SSD, equals the sum of the squared deviations of each score d from the mean difference score, d bar. In this example, the sum of squares equals 12 minus 9 squared, plus 6 minus 9 squared, plus 19 minus 9 squared, plus 7 minus 9 squared, plus 1 minus 9 squared. This works out to 3 squared plus minus 3 squared, plus 10 squared, plus minus 2 squared, plus minus 8 squared, which works out to 9 plus 9 plus 100 plus 4 plus 64, which works out to 186. In Step 4, we calculate the sample estimate of population variance of the difference scores, S squared d. The sample estimate of population variance of the difference scores, S squared d, is equal to the sum of squares, SSD, divided by the sample size, n minus 1. In this example, S squared d is equal to 186 divided by 5 minus 1, 4, which works out to 46.5. In Step 5, we calculate the sample estimate of population standard deviation of the difference scores, SD. The sample estimate of population standard deviation of the difference scores, SD, is equal to the square root of the sample estimate of population variance of the difference scores, S squared d. In this example, SD is equal to the square root of 46.5, which works out to 6.819. In Step 6, we calculate the estimated standard error of the mean of the difference scores. The estimated standard error of the mean of the difference scores, S sub d bar, is equal to the sample estimate of the population standard deviation of the difference scores, S sub d, divided by the square root of the number of score pairs, n. With these data, S sub d bar is equal to 6.819 divided by the square root of 5, which works out to 6.819 divided by 2.236, which works out to 3.05. In Step 7, we calculate the t-value of the mean of the difference scores. The t-value of the mean of the difference scores is equal to the mean of the difference scores, d bar, divided by the estimated standard error of the mean of the difference scores, S sub d bar. In this example, the t-value of the mean of the difference scores is equal to 9 divided by 3.05, which works out to 2.951. In Step 8, we find the critical t-values. There is no previous evidence or previous evidence is inconclusive. The rejection regions are below the negative critical value in the lower tail and above the positive critical value in the upper tail. We need degrees of freedom to look up T critical value. Degrees of freedom equals number of score pairs, -1 equals 5, -1 equals 4. With tails equals 2 and alpha equals 0.05, we need to look up the critical value for DF equals 4. Use interactive table 7 to find the critical value. With 2 tails and alpha equals 0.05 and DF equals 4. Use T equals 2.776 from the table below. The negative critical value is -2.776 and the positive critical value is 2.776. We close this window to return to the analysis, which shows the negative critical value is -2.776 and the positive critical value is 2.776 with 2 tails and alpha equals 0.05. In step 9, we test the hypothesis. The t-value of the mean of the difference scores, 2.951, is above the positive critical value of 2.776. Reject the null hypothesis. In addition to the 25 example problems, we can work step by step through an unlimited number of new problems using the Generate button. The Edit Data button can help us create problems with customized input. Instructors can use this function to create problems with complete solutions to use on exams, in class, or for homework. For printed output, we can print the question. Or we can print the question with the complete solution. The free website has statistical analyses in all of the most common areas in statistics. Statsproblems.com also has a mobile version so you can access the site from anywhere. For help with statistical concepts, HelpMeWithStats.com is a free website that has more than 70 tutorials, as videos, or as self-paced slideshows. In addition, HelpMeWithStats.com gives you free access to a comprehensive stats textbook with more than 685 review questions. Thanks for watching. If you find these resources valuable, please share Statsproblems.com and HelpMeWithStats.com with your friends and instructors.